Okay.
Good morning, everyone. My name is David Schlitt. I'm the Business Development Manager here at Origin. I'd like to welcome everyone attending this webinar today. Also on the panel is Lyle Fisher of Capvidia and Cecil DeLine, our lead engineer here at Origin. I'll leave it to Lyle when he comes in to give a little bit more background of what he does with Capvidia. As the title suggests, we'll be looking at automating the inspection process with SOLIDWORKS, and we'll be using add-ins from Capvidia and Origin. Quintessential to this automation process, or the starting point, if you will, is the concept of the digital thread. Beginning with the MBD that can be created in any number of CAD systems and imported into SOLIDWORKS and used throughout the inspection process. Lyle will present on behalf of Capvidia and show us what FormatWorks is capable of doing. And next, we'll turn it over to Cecil to have a look at how Checkmate product utilizes the MBD and carries that digital thread through the inspection process. We'll generate or show you the generation of programs to drive CMMs, or those same programs can be used also as a soft gauge for laser scanning applications, where that program is used, as I mentioned, as a soft gauge to extract inspection data from a point cloud.
All right, well, thank you, guys. My name is Lyle Fisher. I'm with Capvidia. Capvidia has been a long-time partner of SOLIDWORKS. We actually started working with SOLIDWORKS in 1994. And today I'm going to show you one of our MBD solutions, which is targeted for SOLIDWORKS users. So this is a gold certified product. We awarded that in 2004. And we are highly recommended by a lot of SOLIDWORKS people, a lot of SOLIDWORKS users and resellers. So I've been doing this for quite some time. FormatWorks provides SOLIDWORKS for a few extra things it doesn't do very well or doesn't provide at all. And first of all, we have a great CATIA solution. I've been well known for moving CATIA in and out of SOLIDWORKS back and forth. We have a model-based definition solution. We have tools for precise translation, other productivity tools. So if you have other needs beyond model-based definition, please contact us. But today I'm going to kind of shorten this up to tell you just what we offer in terms of model-based definition for SOLIDWORKS. So with FormatWorks, we can import any MBD data into SOLIDWORKS, whether it's coming from Creo, NX, CATIA V5, V6, or from the neutral file formats, STEP, AP242, and QIF. Now, we fully support SOLIDWORKS MBD. We can bring the models into DIM Expert mode, which is exactly what the folks from Checkmate and Origin need to have and can utilize. We have full visualization capabilities, save views, we maintain those. We can also import this MBD as curves or sketches for other use cases inside of SOLIDWORKS. And we can also export this out of SOLIDWORKS to the neutral file format STEP, AP242, and QIF. I just want to kind of give you a little difference between us and SOLIDWORKS MBD. SOLIDWORKS MBD is only for native SOLIDWORKS models. Well, so basically you design something and use DIM Expert and other tools to fully annotate the model. But there's no import available within SOLIDWORKS to bring MBD data in from other sources. So with FormatWorks, we bridge this gap, provide this solution so that you can import other data with MBD into SOLIDWORKS and utilize it. Okay, as I said, we can bring things into DIM Expert mode where it can be edited, modified, viewed, or whatever. I mean, this is coming in from CATIA, for example. We can make this available for you to work directly inside of DIM Expert. So semantic PMI, we maintain the link, so when you touch something, you know exactly what it's connected to. We're maintaining that semantic relationship. Obviously, you can modify or edit it, and you have the DIM Expert property page. So those of you that are familiar with the SOLIDWORKS DIM Expert, we're bringing this MBD from any data source into SOLIDWORKS, so we utilizing DIM Expert. So let's talk a little bit about what we provide. You have our basic CAD model. As I said, we can import the MBD from any CAD source. We have it's editable within DIM Expert, as I just said. Of course, we maintain the semantic links between the GDT and the geometry. We can also import this data as curves or sketches, I said earlier. We bring in the parts part number notes, revision, all the metadata, and we also bring all the saved views in, which is also important because that's a lot of times how the MBD information is relayed to you, so you can work with it inside of SOLIDWORks. Here's a simple illustration of CATIA V5 on the left, SOLIDWORks on the right. I'm highlighting the PMI in CATIA and cross-highlighting. I'm also highlighting in SOLIDWORks to show you that this full semantic representation is maintained. So it's really kind of a neat solution to bring all this PMI, GD&T into SOLIDWORks so you have the same access and information that you would have in CATIA. Okay, briefly, I just kind of summarized here that we import any MBD data into SOLIDWORks from all these different sources. Full support of SOLIDWORks MBD. You can import in different methods. But the big question is, besides this visualization and using it for drawings or e-drawings, what else can you do with it? And that's where our friends from Checkmate come in today, because Checkmate can directly use this information for their CMM programming. I said the direct MBD import into DIM Expert from any CAD system is readily usable by Checkmate. You don't need a CAD seat to do this. You don't need a seat at CATIA, for example. You don't have to manually enter the GDT back into SOLIDWORks. And of course, this eliminates a lot of potential human errors, and it lowers your costs, increases your quality and efficiency of the entire measurement process. So thank you, guys. If you have any questions on this or have more information, please see our website. We have also do provide MBD solutions for all CAD systems, but for today, this is what we offer for SOLIDWORks. And with that, I'll turn it over to Cecil.
So this is Checkmate. You can see that you know, with the we've got the icons and the ribbons and everything, that we're also fully integrated inside of SOLIDWORks. You can see the CAD model in front of you with all of the PMI annotations that were imported in. And over on the right-hand side is what we call our Checkmate programming browser, and this is where we create kind of like a feature tree of all our measurements that we're going to be sending out to a CMM or using as a soft gauge. So basically what we want to do now is we just have at the press of a button over here in the top left on our, we're going down through and evaluating all of the PMI, all of these annotations, and we're automatically building the measurements in this measurement tree on the right-hand side. Now we actually take the information, the tolerances, we take the nominals from the CAD model, and we add CMM sensor things such as approach and retract, and how deep into the holes I have to go, and we put all that together and we create these measurements in our programming browser automatically. Now, what do we see here? Well, if you look in the graphics area, all of the measurements here are represented by these gold features, and you can see some blue lines, which basically just represent connectors, kind of showing you the order of the program. Now, if you look over in the programming browser, you can see, for example, we'll look at this guy here, Datum B. There's a perpendicularity called out 0.5 back to A. And if we go over to the annotation here, you can see where we extract all of this information. And then there's the diameter up above here. We extract all the information, the tolerancing, all the reference, GD&T, and that goes on to these features. Now, once we have these features in here, we haven't created any code. And this is the big thing here is there's no actual code. There's no DEMUS code for you to have to learn. This is just a graphical program. And very easily I could say, for example, you can see at the bottom here, plane 3 and plane 4, the bottom two features. I could just go in and take plane 4. If I want to adjust the program or anything like that, change the order, I can just drag and drop, and you can see I just move things around. So it's very easy to reposition items, change the order, and do whatever whatever order you need it in for your specific application when you're running it on the CMM. Now, what you can also do is we can just edit any of these features, and you can go in and, if you have to change the nominals, or maybe you want to, you can see over here with Datum B is a cylinder. Maybe it's just calling out the perpendicularity and diameter. Maybe you want to, go into here, these edit screens, and you can turn on the X, Y, and Z also. So you have full editing capability here in a graphical environment. What I'm going to do right now is I'm just going to switch to another file here. Looks very similar, but what we did is we just added a few probe moves and some probe rotation. And what we've got here is we've actually sent this program out to a CMM. You can see actually in the bottom left corner, I'll just zoom in a little bit, you can see the blue connectors kind of going through the part here. So just using very quick short keys on the keyboard, I'm just going to go in and click on this guy and just drag him out there and insert a probe move automatically to go around that corner. So again, we have a lot of editing capability that's graphical based to make it very easy to set these programs up. You can probably, using the Checkmate tools, you can probably increase, you get a program done probably 80 to 85% quicker than traditional methods. We also have the capability, I'm just going to highlight a couple of these guys. We can do full simulation, so you can see what's going to go on. And when we're in assembly mode, we also support collision detection also. Okay, so this is a program that was all ready to go. We exported it out to the CMM, but one thing to remember is we have kind of two things here we can do with this. We can export this program to a CMM to run and get some results, or we can use this as a soft gauge where we can use it with a laser scanner, and I'll get to that in just a minute. I'm just going to stop the simulation here. Okay, so I'm just going to go to I'm going to bring up let's see, let's make it nice and easy here. I'm just going to unhide turn on the color map. There we go. So what you see here is what we call a color map, and this is basically showing all the from a laser scan that we've loaded into the CAD file here and overlaid it onto the CAD geometry. And this is showing the deviations of the measured part with respect to the nominal CAD. And what we can do is we have this MBD program that we created, all the PMI information here. We can extract that information of all these measurements from this laser scanner. So the key is that regardless of whether we get the results data from a CMM or whether we use a laser scanner and extract the results from that, we get a set of results. And I'm just going to switch over to what we call our reporting browser. This is a standard common way of showing reporting the results. And you'll notice first thing is that all the feature names are retained. Plane 1, hole 1, datum B, for example, datum C. And we have the feature control frame. You can see the deviations. This graphic probably looks pretty familiar to you guys on CMMs, pretty standard stuff, and some flags. And we can really customize what we want to actually see in this. I can turn on the tolerance column here so you can see the tolerance. And so we can go through this and create this report, and we can output it to PDF or whatever. So this is kind of the standard reporting method. We do have other methods of reporting the data, and I'm just going to go in and quickly turn off the color map here. And then I'm just going to hide our segment here just for a second and bring up the set of whiskers. Now, this is another form of reporting, is where we can see everything graphical. And the whiskers, if you've seen whiskers before, they basically represent the direction and the amount of the deviation. So they're the ones you can see on the left side, for example. They're kind of pointing into some of them are pointing into the part, some are pointing out of the part. I can turn the shading off here, and you can see the whiskers pointing into the part, showing that this edge is kind of on the shy side. So this is another kind of report that we can do. This is more of a graphical report. And I'll just turn our shading back on. Another kind of report we can do is we have a lot of Excel templates in our system, so we can export the data directly to customized templates that you can customize or that we already have done. This happens to be a 9102 used in the aerospace. You can see all the features that are in here, and we automatically fill those at a press of a button. So those are the kind of reports we do, and I'm just going to switch over to a final part here to drive home one more important thing here. This part here, you see a color map. This is laser scanned, but this is actually an average of 5 parts. And so we know that when you're going in and to make changes in your process or in your tool, you can't make a decision based on a single part, because that part could be out of spec. So what we have here is the capability from our color plots here to be able to show this average of 5 parts, but more importantly, the actual data that we see in our reporting browser here. You can see we have the 5 samples, driver part 1 through 5. And you can see the individual data. I can go and turn off these, and now we're just basically looking at the average of each of these samples for these points. Now you can see again, this is customizable. You can see it's like an X-bar chart. For example, in the top one here, the magenta is the mean, the red and the blue are the control limits. It's kind of like looking at a histogram straight down. But there's other things that we can turn on in here to take a look at. Of course, we want to see our PP and PPK because we don't want to make any adjustments to our process if it's not in control. You know, we can show standard deviation. We can show the control limits. You know, we can even show the process tolerance here. And this is a suggested tolerance showing based on the sample you've got a suggested tolerance to use if you have to go back to your customer and say, hey, this is the tolerance that I need for this feature. So you really need to use stats and be able to look at these process indices in order to make good decisions. Again, all from the PMI information that was imported from the system. Having said that, I'm just going to turn this back over to David.
Okay, so what you're seeing here, the whole is sort of a helicopter view of what everybody's trying to do. You want to shorten that time to get your products out to the market and improve the life cycle management of that part or product over a period of time. And everything we've shown you today is geared to do just that. So this is the overlying what everybody's trying to do, and we're for some reason, Cecil, we're having a technical difficulty here.
Oh,
there it goes. And how all this works is it's from this complete process, starting from what Lyle showed you at the beginning, following that digital thread all the way through. We want to eliminate the reentry of critical information. We save time, we save errors, bringing all that information in. I think what we're seeing from a technical point of view is just slowness of the WebEx here. It's not advancing through the bullets. Okay, there we go. In this entire process, and I think if anybody's attended any SOLIDWORKS presentations or demonstrations, everybody wants to do everything in 3D. Get out of that habit of making 2D drawings and circulating 2D drawings. Get all that information in the 3D model and use that to pass along to everyone up and down the chain, or should I say down and up the chain. If you're getting, like we saw earlier, models created in other CAD systems brought in through FormatWorks and then back up through engineering so that everyone can see the results. We greatly reduce the programming time. If all that information is already in there, obviously we're not re-entering tolerances and everything. It drastically shortens that programming time to get to a CMM or get to where you can use it as a soft gauge for things like laser scanners. And we didn't mention there, more due to time, we used the example of the laser scanner, but that could have been points taken from any kind of a laser tracker or ferro arm or roller arm, any kind of articulating arm, any kind of discrete XYZ points from anywhere, and bring them in and evaluate them using the GD&T that's in the model. Okay. And the whole aspect of increased operability. We're doing this all within sort of one system. We're not creating islands of information where we got, geez, we ran this on that scanner, so we've got a report that's in that database over there, or that CMM results file. And all of this is maintained within the SOLIDWORKS environment. And like I said earlier, you can run this back up the PO, back up into engineering. They can see those whisker diagrams in their environment, what's going on with their part, how do we best fix it, that type of thing. And just to reiterate, we're really automating that whole process. Okay, and that's pretty much what we've got to say. We ask that you keep your questions and answers to the end. You can enter your questions down below in the box. Cecil, I'm running blind here. I can't see if there's any questions. Just a minute. Wait. You'll have to read them out. But we'll take any questions and answers now. But we've also recorded this presentation, and we'll email a copy of it to all the attendees, along with contact information for those people who want to learn more about what they saw today, whether it's their questions are with Origin or with the Capvidia with Lyle. So we'll get that out to you. And now, Cecil, if you can just fire off the question.
Will the CMM functionality work on Zeiss machines with Calypso software?
Yes.
Okay, I'll take that one.
Yes.
All modern CMMs.
That wasn't a hesitation. I thought you were going to answer. So I
thought you were going to answer.
Okay. Sorry.
Okay.
Yes. There's also the capability to, with Zeiss through Checkmate, other Checkmate products which we didn't show today, to read in existing Zeiss programs. And information, as opposed to having to program it. If you've got existing programs you're already running out there, load in the programs and the results and go from there in this environment. So the answer is yes. We could.
Yes, and the next question is similar. Can the CMM program generate support touch probing technologies, VAST, SPX, ScanPass?
I think you got that one, Cease. Yes.
Yes. Absolutely.
Yeah.
Also, for the same person, scanner point clouds. What filtering capabilities are there, and is there any auto filtering done to the point clouds relative to the CAD as a pre-filter? Okay.
Are you going to take that one? Yes, there is a filtering process. We didn't bring up the user controls and the default values, default screens that the user can boil that down. If it's a big part and you've scanned it densely, you can. And then the other part of that factor of this is how good a computer you're running on, how many processors you have at your disposal, how much you need to filter that down. and in the case of making those final inspection reports, we're looking from the program, from the soft gauge out. Okay, so that things that are outside the range, we don't care if there's points out there, and those outliers out in space, that doesn't matter. They're not being considered anyways. So yes, we have filters, and on the other hand, they're not as required as much because of the technology we're using to create those reports. Okay, I mean the color maps, management loves them, and so do engineers, because you immediately see right on the screen what's going on. You don't have to. You're not looking at a page with XYZs all over the place and trying to figure out what's happening here. But when you get down to that FAI submission, you really want to know specifically for those holes, those features, those surface profiles, exactly what the details are, and you're going to base any corrective action based on that as well, as opposed to trying to figure out from that color map what needs to be fixed. Okay. Back to you, Cease.
And we have another one kind of just on the topic there you were discussing. The next one, it says, how is scan data points assigned to tolerance and datum features? And I guess that's all part and parcel of our substitute feature. And when we extract the information from the scan for those points that we've created, we automatically assign that to those features. And for example, things like holes and circles, from scan data, it's what I was saying, what we call substitute feature generation, where we can actually create a circle measurement from that scan data as far as results go. Someone says...
Just a little further on that, too, another area that we didn't get into, more on the manufacturing engineering side, where you saw simple reports. We can bring up our root cause browser with all that data in it and reassign, let's say, after the fact you wanted to assign something else as ABC and refit all the data with that. It's just basically as you realigned it to those datums, okay? So it's a very powerful tool. Okay, go ahead, Cease.
Next question is, I'm not too sure I totally understand, says, what kind of part program Checkmate generated? Well, I guess that means what kind of CMMs that we output to, which is basically any modern CMM, we can output a program to them, and it's usually via the Demas language.
Yeah. Yeah, good question. I mean, they're all good questions. That one in particular is something I think we forgot to mention during the presentation, that output to just any modern CMM.
Oh, and here's another one. Does Checkmate have the function of extracting features from a point cloud? Yep, we just talked about that.
Yep. Yeah, in the example shown, the original alignment automatically aligned. The point cloud on your laser scanner is going to be somewhere in outer space. There's an automatic alignment to the CAD model, so the initial color map you see is basically point cloud aligned to the CAD model, and then you later go in and refine it to align it to the whatever your ABC coordinate system is to get more accurate results. Okay.
Someone says here, our color mapping is beautiful. To get that look, do I need to scan the part with more points more evenly? It looks like it's asking. Obviously, the more points that you use, and the more of the part you get, the more the part you scan, the better looking color map you're going to get. You're going to have troubles if you have a big part and you just scan a little corner of it. You're going to have trouble fitting that in there. But absolutely, I think the answer to that is yes. Nice even points going all along the part. So the software will be able to automatically align a scan point cloud to the nominal model. Absolutely.
Yeah.
And that's it for our questions.
Okay. Lyle, you must be feeling left out. There was no questions directed to you. But I can only surmise that your presentation was so good and you covered off all the details that people had no questions. Thank you very much.
You're welcome.
All right. I guess that concludes our presentation for the day, and we really, like I said, we'll get links out to a video on YouTube or some other such video that you can review this later at your leisure, and some contact information. If you have any more questions or want to learn more about what you saw today, feel free to chase after us. Okay. Thank you very much, gentlemen. Bye.
Bye now.